From ContainerDays Hamburg, this video is proudly presented by Dax IT.
A few words about myself. My name is Alex, staff engineer at Binary. At night, I'm making some Go videos on this YouTube channel called Package Main. Cool, so get started. Have you ever unplugged your computer because you were frustrated? Maybe in the world of PCs, I certainly did. And in a world of software, a similar concept exists. It's called a hard shutdown. Such abrupt termination can cause problems like data loss, partial data, system instability, connection errors, so forth. Luckily, there is a better way. Probably heard it, graceful shutdown. So, in a nutshell, a graceful shutdown is a polite way of stopping a program, giving some time to finish things up nicely. And usually, a good graceful shutdown will have the following characteristics. It completes some ongoing requests or tasks, so that depends on your program, right? Could be, maybe pops up events, HTTP requests, so forth. It releases usually some critical resources. That's maybe not always necessary, but sometimes it is. Most importantly, it saves information to the disk or a database, kind of to be able to resume later if needed. And just not to have partial or broken data or bloated disk and so forth, right? And usually stops accepting connections, telling the world that I'm about to shut down. Please don't contact me anymore. So in this presentation, let's dive into the world of graceful shutdowns for Go applications running on Kubernetes. We'll be focusing mainly on HTTP servers, though the same principles apply or should apply everywhere, also not necessarily for applications running on Kubernetes. And we will dive into the processes and signals. We will give overview to Kubernetes pod shutdown process. And then at the end, we'll try to develop an ultimate and probably HTTP server with graceful shutdown in Go. So one of the key tools for achieving the graceful shutdowns in Unix-based systems, so not necessarily in Go, it's this concept of signals. And signals are the software interrupts that are sent to a program or process to indicate that some important event has occurred. These signals can be sent from another process or program, from the user, for example, when we press Ctrl+C in our terminals. Also could be sent from the OS or kernel itself. For example, the signal SIG-SEGV, somewhere here, aka segmentation fault, is sent from the OS itself. And you can usually print on your machine with kill -L the list of available signals. You can also use the same kill command with -S, give it a signal name, and send a signal to a process by its ID. So the list is huge, you've probably seen it. However, the list that's relevant to graceful shutdowns, or just shutdowns in general, it's much shorter. So we have SIG-term, that's the termination request. That's what Kubernetes sends when shutting down the pods gracefully. There is SIG-int, happens when you press Ctrl+C in our terminals. You've probably seen that already. There is infamous SIG-kill, my favorite one, pretty much kills the process immediately. There is no way to catch it or ignore it. And there are a few others like SIG-quit, when you press Ctrl/, and few maybe less used today like hang up, signal, and few others. So coming to a Go part a little bit closer, what's the default behavior in Go? Especially what happens to let's say long-running Go program when you press Ctrl+C in our terminals. And by default, when Go runtime receives such termination or interruption signals, it exits immediately. There is actually internal catching of the signal, but then it doesn't do anything, just exits. But you can catch the signal manually, and that's what we'll be doing later. And this specific signal, SIG-quit, when Go runtime receives the signal, before exiting, it will print the full stack trace of the Go program to the terminal. And that can be actually quite handy when we are debugging maybe some long-running, unresponsive Go program, and can be controlled with Go traceback environment variable. Cool, so why did we talk about signals? That's because Kubernetes also uses them when shutting down the pods gracefully. It follows a very specific shutdown process, so let's review that quickly. At first, the pod is set into terminating state. and is then being removed from the endpoints list of all the services, meaning that it no longer gets any traffic. However, the applications or containers in this pod are not affected yet. They're not aware of this event just yet, so just not getting any traffic. Then the pre-stop hook is being executed if defined. And pre-stop hook is this special command or HTTP HTTP request that can be sent to a container to notify about the shutdown process. Can be quite helpful when you may be running some third-party application or some software that you don't have control over, meaning that you can't modify its source code, so maybe you can use pre-stop hook there. After that, the kubelet sends seek-term signal to process number 1 of each container. So remember, in pods there can be multiple containers, so the seek term will be sent in parallel to all of them. And here your application needs to react to that. Even maybe if you're only using pre-stop hook, you still need to verify that your application works correctly when you receive seek term, because like Go will exit immediately. And yeah, you need to do all this action that we described or talked previously, right? Stopping accepting new connections, kind of gracefully finish everything, save everything to the disk. And that takes time, right? So pre-stop hook takes time, seek term handling may take time. And Kubernetes will wait for that with this specific deadline, which is called termination grace period. Which is controlled by this environment variable or just configuration variable, termination grace period seconds. And after this deadline, when this deadline approaches, or when we reach this deadline, if there are still any running containers in the pod, the seek kill event will be sent. And as we already know, seek kill cannot be caught or ignored. So all these processes will be stopped and containers deleted, and then Kubernetes will clean up everything. So yeah, kind of very important configuration parameter. That's how it may, maybe I'm still in the way. That's how it can look like in the Kubernetes manifest, for example. So it's defined on the container level. There's a lifecycle object, pre-stop hook, for example. In this case, maybe it's some bash command. Again, it could be a HTTP request there. What else? Funny enough that we can change the signal that's being sent by kubelet. So default one is seek term. That's the last line. We can change it to something else, right? We can maybe get some custom signal if you want to. And termination grace period seconds is controlled on the top, on the pod level. Few words on these variables. So again, by default, it's 30 seconds. Can be set to 0 to completely disable graceful shutdown, make it forceful or hard shutdown. The countdown begins before we execute the pre-stop hook, right? So you may spend some time on pre-stop hook, then signal handling, and that leads us to the next, or to the last point, that it's a good practice to reserve some extra time, making sure that you have enough time to gracefully shut down, because otherwise, somewhere in the middle of this process, you will get a seek kill, and all this graceful work was for nothing, and maybe it will be even worse than without a graceful shutdown. The next one. So this, I drew that, by the way. I mean, Figma. Anyway, with this kind of brief knowledge of signals in Unix-based systems and Kubernetes pod shutdown process, let's dive into the core application part. As I mentioned, we'll be focusing on HTTP servers, but again, the same flow should apply everywhere. Here's the basic HTTP server in Go, which doesn't have a graceful shutdown. And by the way, that's maybe totally fine, because maybe you're running some internal application or command line tool that the graceful shutdown is not needed there. But even for maybe low traffic application, it won't hurt having some extra lines to gracefully shut down your program. So let's review that quickly. So we have the Redis connection. We start the server on port 8080, and then we have the increment endpoint, single endpoint that just increments some counter in Redis, just prints the status code, nothing fancy here. At the end of the presentation, I'll leave a link to a GitHub project where I have the version of the server with graceful shutdown and one without, Kubernetes manifest, and some load testing, so you can actually verify that we are not losing any requests and not losing any data, specifically this counter in Redis. That's how we confirm that we don't lose anything. Cool, so You might assume that because there is no graceful shutdown, it has the following downsides, or it might have, depends on the program, right? We can get some various connection errors, like connection reset, connection reviews, what others, like a socket hang-up errors. We're not closing resources, so Redis connection in this case, but could be kind of much more serious problems like maybe file descriptors and database connections. But most importantly, we are missing or having some dirty data. Again, Redis example, very easy here, but it could be some partially written data, again, some trash on your disk, right? Maybe transaction that you didn't roll back or didn't commit and so forth. And usually applications can become quite big, right? Your endpoint may do multiple things and maybe some in the middle you get shut down and yeah, try to figure out how to revive this program. So cool, we want to shut down gracefully. Where do we start? Remember, there is this pre-stop hook that we can use, send to our program, but because we control the application, we change the source code, you get more flexibility with catching the signal. And in Go, you can do it nicely with os/signal package. There are actually two ways of using that at the moment. So one is using the buffer channel of size 1, where you specify which signals you want to catch, and then you read from this channel in the blocking matter, and kind of here you basically catch your signal right at the last line. That's one way, and a little bit more modern. I mean, Go 1.16 was already, I don't know, 5 years ago or something. A little bit more modern way is to use context, and in Go we like using context because even though it functions in absolutely the same way, contexts are nicer because you can propagate them to other functions, other places. You can cancel them, maybe you can nest them, extend them with some additional information and so forth. But functionally, it works up in absolutely the same way, right? So the last two lines are pretty much identical. Cool. So we caught our signal. Now it's time to shut down, right? But we still have a few questions I would love to go through. So the first one is, how much time do we actually have? Remember that in Kubernetes, we are bound to this termination grace period, and we want our Go program to be aware of that. So a general rule of thumb is maybe leave some 20% as a buffer. So if your termination grace period is 30 seconds, try to finish everything in the Go program in under 20 seconds. And we can do it nicely in Go using contexts and timeouts, right? So we can control this program, this process to some extent. Maybe not everything, but pretty much the majority of this time. Another question is, so we would assume that by receiving the SIG-term event, we are not getting any more connections, which is generally true. However, for some cases where there are external load balancers that may rely, or maybe like be a little bit slower, and then they rely on Readiness probe, there could be a short window where you still get some connections, and that's been proven. A good strategy here would be to fail the Readiness probe first. So yeah, let's do it as our next step. We will fail the Readiness probe first, right? We will add another endpoint for the Readiness probe. You probably already have it if you run your Go application on the Kubernetes. If not, it's easy to add. We can also use, in this case, I use atomics nicely because you can, once you receive the SIG-term, we swap this atomic flag to true, and our Readiness probe endpoint starts returning serves an unavailable status code. And we can use it from our main.go. I mean, usually it's on the health / health z, but doesn't matter, it's on slash endpoint in our case. And at the end, when we receive the SIG-term, we kind of swap this toggle to true and start failing the Readiness probe. And we control this with time.sleep in this case, so we want to do that for some specified time, so for 5 seconds only. Control with constants. Could be another value for your program, could be controlled maybe with some environment variables, doesn't matter. But what's important to understand is that the server is not affected yet, right? We are still accepting new connections if there are any. We are still processing the ongoing ones, so no changes to the server just yet. There's the current diagram at the moment. So SIG-term receive, failing the Readiness probe for 5 seconds. Let's go next. Now we would assume that there are no more incoming connections. we can obviously make more checks that there are actually no more connections, but let's just for now pretend that readiness probe was enough. And it's time to do the main work, right? So stop and accepting new connections and finish ongoing ones gracefully. So give them some time to finish. And that's what http.server can do, especially this method called shutdown. There are a few methods. There is a close method on server, but this one doesn't wait for ongoing requests. So for graceful shutdowns, the best method is shutdown. It can nicely receive the context, and that's useful for us because we can define some context with timeout. So again, we can control this time. We don't want this shutdown to happen indefinitely. So we cap it to 10 seconds in this case, so controlled somewhere there. And the shutdown process will then actually error out if under these 10 seconds it wasn't able to shut down the server, or maybe there are still any running functions there. And in this case, we'll need to send the context cancellation and give kind of this cancellation another time, 5 seconds in this case. But we'll come back to the lower part a bit later. So far, here's the updated diagram, right? So we are failing the readiness probe for 5 seconds, and then for a maximum of 10 seconds, we are finishing the ongoing requests and stopping accepting new connections, right? So maximum 10 seconds could be pretty much fast. If your endpoints are quick enough to finish, that will be pretty much fast. Cool, so coming back to this context point, HTTP server in Go has a really great feature or a property called base context. There is another one, connection context, and maybe a few others. But base context is great because it's then propagated to all the functions of all the requests, meaning that we can define some root context or base context at the top level here, and kind of utilize that. We can cancel that, right? Maybe do some other actions. And that's how we use it actually. That was the code from a few slides back, right? After the shutdown, we cancel this base context. We can do it actually before checking the error, because if there are no more functions running, it will just do nothing. There won't be effect. And if there are any functions running, the cancellation will be sent to them. And we'll kind of wait for 5 seconds. So this hard shutdown wait variable is 5 seconds or constant. Again, could be controlled to your program. Yeah, obviously it will only work. So this cancellation of the context, if your program is context aware, right? If all the handlers actually respect context and act on such errors like cancellation. So instead of doing something like that, where let's say you have a request handler that takes the request, that maybe calls a process function, then process function calls cache.increment. If request is being cancelled in this case, this process function will know about that, right? It will just still march and do its work, and who knows how long does it take. Real function can be much longer. And cache.increment also won't know about that because it uses the context.background. So instead of doing something like what we've seen before, pass the context everywhere, right? So our process function could take the context of the request. So HTTP request has this function .context, and we can pass it everywhere. And when I say everywhere, not all functions need to receive context. For example, maybe there are some atomic and quick functions like summing up two numbers. You obviously don't need to send context there, but usually I would say if the function works with I/O, for example, or takes some time, you better pass the context there. And also, yeah, try to avoid using context.background, context.todo, and also some functions, even in Go standard library, like time.sleep, are not context aware, but you can define some workarounds there. That's the updated diagram, right? So after finishing the ongoing requests, there's this dotted part, which is optional, canceling ongoing requests for 5 seconds if there are still any, right? So that will happen only if we error out. And as the last step, we are closing critical resources. So in this case, it's Redis connection. Again, could be database connection, maybe kind of WebSocket connections, connection to external services, and so forth. it's very important to do it at the very end of your program, making sure that there are no more functions and coroutines utilizing those connections. And at the end, we exit with explicit exit code. I know that's optional, but usually graceful shutdowns exit with successful error code 0, because the program exits gracefully, right? There are pretty much no error happened in this case. And that's the full diagram now of the shutdown process. So releasing the resources, and ideally it all feeds under these termination grace period seconds, and we maybe have some buffer. So here we focus on HTTP server, though as you may already notice, maybe some things would be different, but the same flow would work for kind of other programs, right? Maybe instead of HTTP request, there will be some event stream or like pub/sub messages. Readiness probe is maybe Kubernetes specific, but actually not really. It's a good practice to have if you have HTTP servers, right? And yeah, you may also ask, why does it take so long? So 5 seconds here, 10 seconds there, 5 seconds there. First of all, these numbers are just random, just kind of default ones, though they actually work well for the default 30-second grace period seconds. But it could be controlled, right? So you know your applications better. Some parts can be removed, and kind of these things can be modified. Yeah, and as I mentioned, for those who are interested, there is a project with Graceful Shutdown and without Graceful Shutdown, and you can confirm by running the load test with Kubernetes, and you can actually see that the server with Graceful Shutdown, even without big load, actually doesn't lose anything, which is great. So yeah, go check it out and play for yourself. Yeah, I actually finished quite fast, so I don't know. That's it from me today. Thanks for coming. Yeah.
Thank you.
I told you we'll be quick.
So much. It's no problem to finish early because then we have more time for questions. First one is up, and I see some people typing. Of course, you can use the app again. So, is the HTTP server space context also propagated to the requests context?
Yeah, I think it is, and there is also connection context that's specific for each connection. But for a graceful shutdown, if you override your base context with something else, so then when you get request context and pass to your function, it will error out when it's cancelled. So that's why it's great. Obviously, your function inside. So imagine you get this request.context, then you propagate it to all other functions. Maybe you kind of add another information to that, so your context grows, and maybe you branch it to some point. But if you don't lose this context throughout the stack trace, if the main base context is cancelled, then yeah, you'll get an error at some point, and you need to work back and kind of cancel gracefully, right? And maybe do some actions.
Thank you.
This. Oh yeah, you read it first.
I mean, but we go for the Go routines, right?
Yeah, yeah.
Good. What about other Go routines next to the server?
That's a great question. So the example that we've seen was really simple, just HTTP server, nothing else. Usually you have maybe some worker, right? That just runs in the Go routine, and you also need to shut down properly. So again, in Go, you do it with contexts, or kind of. One option would be to use the same base context or root context and then pass to your Go routine. If that works, you can also, if it's a Go routine, maybe you can work with atomics. If you're brave enough, atomics usually thread safe, but still. So yeah, the main point is your Go routine also needs to know, ideally, if maybe there's a Go routine that doesn't bother to be gracefully shut down. But yeah, if you pass the same root context there, and Go routine maybe doing some action will fail, and you can maybe roll it back. That would be my answer. But yeah, I've seen it. Usually, you need to pay attention to that as well.
Awesome. Is there a way to read the configured timeout from within the pod/container?
Oh, great question. Not sure if I thought about that, but what we've done was kind of environment variables, right, or just rely on the default one, which is 30 seconds. I think here people want to read it from Kubernetes manifest maybe somehow. I mean, you can use Kubernetes API, obviously, but your Go service probably doesn't have access to that. I mean, ideally it shouldn't, right? So I don't know. I don't think it's possible, honestly. You need to figure out another way or just rely on the default 30 seconds. Say. Cool.
Cool. Looks like it was a perfect talk, answering all the questions, that there are not so many in the afterwards. So thank you so much for your talk.
Thanks very much.
It was a pleasure having you here on stage. Again, a warm round of applause.
Thank you.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.